In this episode, we talk about large language models and how we can fine-tune them for specific tasks. We'll break down how fine-tuning works, its benefits, challenges, and where it's headed in the future of AI. Now, if you've been following advancements in AI over the last couple of years, you've probably heard a lot about these models. They're basically everywhere right now, powering everything from customer support bots to personal assistants and even creative tools that write music and poetry. But today we're going to break down not just what these models are, but also how we customize them through something called fine tuning. So, what exactly is a large language model? At a high level, it's a model trained on massive amounts of text data to understand human language in ways that were almost unimaginable a few years ago. Think of it like the world's most voracious reader who's read practically every book, article, blog post, Reddit thread, and more. Large language models can generate text, answer questions, translate languages, and even engage in conversations that sound human-like. The reason they're called large is because they contain billions or even trillions of parameters, which are essentially the dials and knobs the model has learned to adjust based on the patterns it's absorbed from all this text data. And it's those billions of parameters that make these models so incredibly complex. They can be trained on general language patterns, sure, but without a little extra customization, their understanding remains pretty surface level. This is where fine-tuning comes into play. Think of it like this. If a large language model is like a library of all human knowledge, then fine-tuning is what makes it your personal guide. It's the difference between a general purpose AI and one that actually understands the nuances of, say, medical diagnosis, financial advising, or just your own brand's specific tone of voice. So, let's break down what we mean by fine-tuning. Fine-tuning is essentially the process of taking an existing large language model and training it on additional specific data to make it more useful for a particular task. Imagine you have a general purpose tool, like a Swiss Army knife, and you want to modify it so it's optimized for a particular job. Maybe you're making it more surgical, or maybe you're giving it a style of speaking that aligns with the company's brand. Fine-tuning does just that. It makes the model better at understanding and responding to specific types of content, whether that's legal jargon, medical language, or even just a friendly, casual tone that matches your personal brand. The cool thing about fine-tuning is that it builds on top of an already trained model, so you don't have to start from scratch. Training a large language model from scratch would require astronomical amounts of data, not to mention computational resources that most people and companies just don't have. Imagine trying to train something with billions of parameters. It's a massive undertaking. But with fine-tuning, you're essentially taking that massive pre-existing model and giving it a specialized layer on top. This makes it way more efficient because you only need to tweak a small subset of the parameters to get the desired output rather than retraining the whole thing. All right, so how does fine-tuning actually work? At a basic level, we take the pre-trained model, lock down most of its weights, those billions of tiny variables it's learned from the initial training, and only adjust a specific part of them. You feed it a new, smaller dataset that's highly relevant to the task at hand. Say, for example, you want to create a chatbot for customer support in a tech company. You would gather transcripts of past support conversations, FAQs, troubleshooting guides, and any other relevant text. This smaller, focused dataset will then guide the model, helping it fine-tune its responses to be more accurate, more helpful, and more specific to that context. One interesting approach that's been gaining popularity is instruction-based fine-tuning. Rather than simply giving the model additional examples of the type of language you want it to generate, you actually structure your fine-tuning data in a question and answer format. It's like telling the model, if a user says this, you should respond with that. This method is especially useful for things like customer service or technical support, where the language is often repetitive and predictable. Instruction-based fine-tuning basically creates a map for the model, so it can better navigate specific questions and tasks without getting lost in irrelevant general knowledge. Another method worth mentioning is something called prompt engineering. Now, prompt engineering isn't exactly the same as fine-tuning, but it works alongside it and is worth understanding. Essentially, prompt engineering is about finding the right way to ask the model for what you want. When you're interacting with a fine-tuned model, the way you phrase your questions or the context you provide can make a big difference in the quality of the response. Think of it as a technique for pulling the right threads in the model's responses without changing the model itself. When paired with fine-tuning, prompt engineering can make the AI seem much more intelligent and responsive. We will get back to the podcast in just a second. This is just a note from me that if you want to learn how to get hands-on with data, you can find courses on Python, Apache Spark, and more at kodey.co.uk. And let's talk for a minute about the technology behind fine-tuning, because it's pretty fascinating. When a model is fine-tuned, what's happening is that specific parameters or weights are adjusted in response to the new data, but the trick is in knowing which parameters to adjust. Think of a model's parameters like a series of layered filters that refine its understanding of language. Fine-tuning operates at the top layers, where the model interprets language, adjusting it just enough to fit the new data while leaving the lower layers, those handling basic language structure, mostly intact. This is what makes fine-tuning so powerful. It reshapes the model's responses without disrupting the core of what it's already learned. One popular approach for fine-tuning in recent years has been low-rank adaptation, or LoRA. LoRA works by reducing the number of parameters that need adjusting, essentially creating a shortcut for the model to follow. This not only makes the process faster and less resource intensive, but also allows for the creation of multiple distinct versions of a fine-tuned model without needing to retrain it from scratch every time. It's like creating a specific lens through which the model views the world, and you can switch between different lenses for different tasks. Now, let's get real about the advantages and limitations of fine-tuning. One of the biggest advantages is the model's improved ability to specialize. A fine-tuned model can outperform a general-purpose model in specific tasks because it's had extra training in that narrow area. For instance, if you fine-tune a model for legal advice, it's going to understand legal terminology and context in a way that a general-purpose model won't. Another advantage is efficiency. By leveraging a pre-existing model, you're able to build a specialized tool much faster than if you were training from scratch. You can save on both time and computational resources, which is a huge benefit, especially for smaller companies or individuals who don't have access to high-powered computing clusters. But fine-tuning isn't a cure-all. One of the biggest limitations is data dependency. To fine-tune a model effectively, you need a clean, relevant data set. And while this might sound simple, curating a data set that's comprehensive enough to guide the model correctly is a lot harder than it sounds. If you're working on a customer service bot, for instance, you need a wide range of interactions that cover the spectrum of customer questions and complaints. Any gaps in the data set can lead to unpredictable results, where the model might respond confidently but incorrectly to a question outside its training data. Another limitation is the risk of overfitting. Overfitting is when a model becomes too specialized in the fine-tuning data, losing the ability to generalize to new situations. Let's say you fine-tune a model for a healthcare application. If you're not careful, it might only perform well on the types of cases or diagnoses it's been trained on, struggling to respond to anything it hasn't seen before. This can be especially problematic if the fine-tuning dataset is too narrow or too repetitive. It's a bit like studying for a test by only reading one textbook. Great if the questions match, but if they don't, you're out of luck. Then there's the issue of maintaining accuracy and relevance over time. Language changes, trends emerge, and even in technical fields, knowledge evolves. So a fine-tuned model might become outdated if it's not periodically refreshed with new data. Imagine a financial model fine-tuned on last year's economic data. It's going to need some serious updating to stay relevant in a changing market. One way around these limitations is something called incremental fine-tuning. This is a bit like giving the model a regular booster shot of new data so that it continues to learn and adapt. Incremental fine-tuning allows a model to retain what it's already learned while absorbing fresh information, keeping it up to date without starting over from scratch. This approach is especially useful in dynamic fields like healthcare or finance, where new research and policies are constantly emerging. So, why all this hype about fine-tuning? Why does it matter so much? Well, in a lot of ways, fine-tuning is what makes large language models more than just fancy calculators. It's what lets them become true assistants, capable of understanding not just human language, but also the specific needs and nuances of the tasks they're designed to perform. It's the difference between a chatbot that can answer general questions and one that feels like it actually knows your product, your brand, or even your company's personality. Looking to the future, it's clear that fine-tuning is only going to become more central as we explore new applications for AI, and the techniques are getting more sophisticated too. We're seeing methods like multitask fine-tuning, where a model is trained on multiple tasks at once, creating a more versatile and adaptable AI. There's also ongoing research into unsupervised fine-tuning, where the model learns directly from interactions with users rather than pre-existing data. Imagine an AI that learns from its conversations with you over time, adapting to your preferences and style. That's where we're headed, and it's exciting to think about the possibilities. All right, I think we've covered a lot today, so let's wrap it up here. Fine tuning is an incredible tool that takes these massive, impressive language models and makes them truly useful, turning general knowledge into specialized expertise. It's not perfect, and there are definitely challenges, but the potential is huge, especially as we refine these techniques and explore new ways to make AI even more adaptable and relevant. Thanks for tuning in to the Kodey Podcast. I hope you enjoyed this deep dive into fine tuning and large language models. I'll catch you next time with more insights into the ever evolving world of AI. Until then, stay curious and remember the future is closer than you think.